Hello everyone. In this video, let's discuss how to write a program to find in mountain array. You may recall that an array ARR is a mountain array if and only if the length of the array should be greater than or equal to 3. There exists some I with 0 less than I less than ARR.length minus 1 such that ARR of 0 less than ARR of 1 up to ARR of I minus 1 less than ARR of I. And here ARR of I greater than ARR of I plus 1 up to ARR of length minus 1. Given a mountain array, mountain ARR, return the minimum index such that minimum ARR dot get index equal to target. If such an index doesn't exist, we have to return minus 1. You cannot access the mountain array directly. You may only access the array using mountain array interface. So these are things they have given about the mountain array. The given array. Mountain array dot get of k returns the element of the array at index. So if you want to access the element which is present on that index, this is how we have to access it. And if you want to calculate the length of an array, you can calculate like this: mountain array dot length. Summation makes more than 100 calls to mountain array dot get will be just wrong answer. Also, any solutions that attempt to circumvent the judge will result in disqualification. So here you should not make more than 100 calls. That is what they have mentioned. So let's take the input array 1, 2, 3, 4, 5, 3, 1. So the meaning is 1, 2, 3, 4, 5, 3, 1. So this array looks like a mountain peak. So which is the thing, but how does a mountain looks? It looks like this. The meaning is from the smallest value it will increase, then it will go to the topmost value, then from the topmost value it will start decreasing. So this is how the array looks. See, 1, 2, 3, 4, 5, and it got, which is the thing, but increasing this phase, then it is decreasing 3, 1. So it is decreasing. This is the given array, and the target value is nothing but 3. So when the target value is 3 occurs twice. So if multiple times the target value has been occurred, we have to return the minimum index value. So in this case, the output is 2. So 0, 1, 2. So the element 3 is present on the index value called 2. This is the question. Now for this question, we have to find the logic and we have to write the program. Let's discuss the logic in detail. So this is a given array. Let's take the index value of an array. 0, 1, 2, 3, 4, 5 and 6. Here we have to find the peak element. So peak element is nothing but this is element I can say, because this is a place and from here it starts getting decreased. So we have to find the peak element. So how to find the peak element is with the concept of binary search. This problem can be solved with the help of binary search, like triple binary search we can say. So first binary search is used to find the peak element. Second binary search is used to check whether the element is present in the first half. And the third binary search is used to check whether the element is present in the second half. This is the logic of the program. Now let's try to find the peak element. So to find the peak element, so we have to take 2 pointers, start and end. So let me take a variable called start and I'll initialize the value as 0. Start is equal to 0. So this is the place it is going to point. And end is going to point to the last index value. End will always point to the last index value. So here the last index value is 6. So as usual, we'll take a while loop, while start less than end. If the start value is less than end, it means that we can go inside the while loop. After going inside the while loop, we have to calibrate mid value. How come can calibrate mid equal to start plus end by 2? So we have to calculate mid, that is the thing, but start plus end divided by 2. So start value is 0, mid value is 6. 0 plus 6 is 6, 6 by 2 which is 3. This is my mid value. So this is start, this is end and this is my mid. Now we have to check the element which is present on the mid index with the next element. So for that I have to write the condition if the array name is mountain array, right? So I can give a mountain array dot, to access the element I have to use a method called get. Get of mid is less than mountain array dot get of mid plus 1. So we have to check the if condition. So which is the thing, but the mid element compared with the next element, if that is less than, for sure we can say that this element is not the peak element, because the next element, when compared with the next element, this element is a smaller element. So when I am considering it as a peak element, when I compare with the next element, this element should be the greater element. But in this case, the value which is present on the mid is smaller than the next element. So 100% we can say that the element which is present on the index value mid is not a peak element. If that is the case, what I am going to do is, the peak element is not present before mid, it might present after mid. So start value from here, it will be moved to this index, mid plus 1. So I can give start is equal to mid plus 1. Okay, I'll close the while loop here. Okay, again what I have to do, I have to go for the next iteration of the loop. Start less than end. Start value is 4. 4 less than 6. Yes, 4 is less than 6. Then I have to find the mid value. 4 plus 6 is 10. 10 by 2, which is 5. So this is my mid. Okay. After finding the mid, what I have to do, I have to check the condition. That is nothing but the element which is present on the index value mid compared with the next element. 3 less than 1, condition is false. Condition is false. If the condition is false, we can say that the peak element is not present after this element, it is present before this element. So what I'm going to do is, before this or up to this, or this can also be the peak element, because this element is greater than the next element. This can be the peak element, or the peak element can present before this 3. So what I'm going to do is, if the value is not less than mid plus 1, I'll go for else part. I'll update my end value as mid, not mid minus 1. Binary search will be giving mid minus 1. But here, why we are not giving mid minus 1 in the sense, this condition, this is value is greater than the next element. So this can be the peak element, or the peak element can present before this. So it can be of 2 cases. So we are taking the mid value, and that I'm going to consider as my end. So this I'm going to consider it my end. Then I'll move the pointer from here to this place. Now again the loop will be iterated. Start less than end. Start is on the index value 4. End is on the index value 5. 4 less than 5, condition true. I have to find my mid value. 4 plus 5 is 9. 9 by 2, which is 4. Which is quotient value will be taken 4. So the index value 4 will be considered as my mid value. So now index value 4 will be considered as my mid value. So this mid will be removed. Now check 11% on mid, that is 5, compared with next element. 5 less than 3, no. Condition becomes false. So end will be moved from this place to this place, because mid value has to be considered as end. Mid is present on the index value called 4. So this will be considered as my end. This also will be end. From here it is moved to this place. Now check the loop again. Start less than end. Start is also on the index value 4. End is also in the index value 4. 4 less than 4, condition becomes false. I'll come out of the loop. I have got my peak element saying that this is my peak element. So the mid value will give me the peak element. Now what I am going to do is, I am going to split the array into 2 halves. So first we have to find binary search for the first half to check whether the target value 3 is present on the first half. If it is present, I'll return the index value. If it is not present, I'll check the second half of the array to know whether the target element is present. If it is present, I'll return the index value, or I'll return -1. So here what I'm going to do is, I'm going to take a variable called low. I'll give my low value as 0, because in the first binary half, for the first array, we have to perform binary search. For that, low value will be given as 0. And for this, the high value will be given as the mid. The variable mid is holding the peak element. So the array has been split into 2 halves. So this is going to be the last index value of the first half. So mid value will be given to high. Now when I go for the next half of the array, we have to perform one more binary search. For that, low value, so I'll give L, because to differentiate for first binary search and second binary search, L will be given as mid plus 1 because mid is having the peak element that is considered as the last element of the first half. So mid plus 1 will be considered as the first element of the second half. And then H high, L denoted as high, that is the thing. But mountain array dot length minus 1. So this will be the last index value. So for these two, I have to perform binary search. With the help of binary search logic, we can write the program very easily. I hope you are clear with the logic. Now let's try to implement this as a program. So here I am going to take a variable start and I'll initialize the value as 0, and for end I am going to give mountain arr dot length minus 1. Fine. And mid value I'll consider to be 0. I'll take a while loop. So here we are going to find the peak element. So start less than end. If this is the case, I'll be calculating my mid value, mid equal to start plus end divided by 2. After that, I have to compare the element which is present on the index value mid with the next element. So I'll be taking an if condition saying that mountain arr dot get of mid less than mountain arr dot get mid plus 1. If this is the case, what is the meaning? The element is present after mid only, so start value will be updated as mid plus 1. If the condition is false, I'll change my end value as mid. That's all. This is the logic. After this, what I can say, I have got my peak element. The peak element is present on the index value called mid. Now I'm going to declare 4 more variables. Low equal to 0 and high value will be given as mid. Performing the binary search for the first half of the array, and L equal to mid plus 1, H equal to mountain arrow dot length minus 1. So L and H is used to perform binary search for the second half of the array. And here we have to know one thing, that in the first half of the array, the element will be in the ascending order, and in the second half of the array, the element will be in the descending order. So the logic will be slightly changed. Now let's perform binary search for the first half of the array. So the binary search logic is while low less than or equal to high. What we have to do, we have to calculate the mid value. Mid equal to low plus high divided by 2. After calculating my mid value, what I have to do? I have to compare it with the target element. So mountain arr dot get mid, the element is compared with the target. If it is equal, directly I can return the mid index. If it is not equal, I have to check one more condition saying that mountain arr dot get mid value is less than the target. If that is less than the target, the element will not present before mid, it will present after the mid for sure. So I'll update my low value as mid plus 1. Else, if this condition is false, I can say the element will present before mid minus 1, before mid value. So I'll give high value as mid minus 1. This is the logic of binary search. And we have written the logic for ascending elements. Now what if we have element in descending order? It's very simple. So here we are checking less than, right? Instead of giving less than, we have to give greater than. That's all. So I'll write one more binary search for second half of the array. Low less than or equal to high. That is H. As usual, calculate the mid value. Low, L plus H divided by 2. If mountain arr dot get mid equal to target. If it is equal, directly I can return my mid value. Else if mountain arr dot get mid greater than target, because here the elements are present in the descending order, because the first half I have got element in ascending order, and in the second half I have got the element in the descending order. So here what will I do? I'll give low equal to mid plus 1. Else I equal to mid minus 1. So even after performing third binary search also, if the element is not present, I should return the value called minus 1. That's all. This is the logic of the program. Let's run the code now. Okay, we have got time limit exceeded, so we have made some logical mistake. We'll check what is the logic mistake. Okay, the mistake is here I have given low. Here it should be L, because second half binary search, right? For that I have used a variable L and H, but I was using the variable called low and high. That is why I've got time limit exceeded. Now let's run the code. Yeah, it passes the test cases. Let's submit the code now. Yes, it passes all the cases. That's all.